Morning, class. April 14th. I've shrunk myself down to hide in the grass from the virus. Today I'm going to be showing you the answers to Monday's work, April 13th. If you haven't done the work, do it first, then watch this video. Okay, so here is the assignment that you did on April 13th, but today's April 14th. I'm going over the answers to Monday, April 13th work. Try the work first before watching this video. Okay, so this was the first question, number 5. It says, here's the teachers' ages in this stem and leaf plot. Notice these are like the 20s, 30s, 40s, 50s, and 60s. It says, how many teachers are more than 50 years old? So more than 50 years old would be all of these. There's the 50s and the 60s. So when I counted them all up, I counted up 26 teachers out of, it said there were 50 teachers, I could count them. 26 out of 50, well, I could say, well, what is that out of 100? 26 out of 50, if I double it, that's 52%. So the answer was D. The next one says to draw a histogram for the teachers' ages. That's over on the side. So erase this. Get this off of here. So I made the ages groups. I said, well, I'll just do the 20s right there. Then I'll do the 30s, 30 to 39. I'll do the 40s right here, 40 to 49, etc. So when I looked at the 20s, I saw there was 1, 2, 3, 4, 5 numbers. So we put a bar up to 5. When I did the 30s, there was 1, 2, 3, 4, 5, 6, 7, 8 people. So I did the number 8, etc. for each one. You can see most of the teachers are pretty old. Next page. Okay, this was a store. Decide what items to stock. A store keeps track of the ages of the customers that come into the store. This is for a 15-minute period. It says, make a dot plot for the data. Down here is the dot plot. Next question. How many people entered the store during the 15-minute period? I counted all of these dots, and there were 25. So 25. Next thing, what is the most important feature you notice of the data? So I'm going to scroll this down a little. And by the way, these were the ages of the customers. This is where we got the dots from. So like, here's someone who's 6, here's someone who's 7, here's someone who's 8. Here they are, 6, 7, and 8. What's the most important feature? One thing I noticed about this data is that the ages. It seems that everybody's either over here or kind of over here. There's nobody in the middle. That's missing. Of course, as the book says, answers may vary. The ages of the customers are very spread out. No customer were between ages of 15 and 24. Next question. What is the mode? Which number came up most often? Well, the number that came up most often, the mode, is the most common number. And it looks like right here, looks like 28. So they say 28. The mode is the age with the greatest number of dots. Next question. E. It says the mean age of the customers is 21. They took all of these numbers, added them all up, and divided by, we said 25 customers, and they said the average age was 21. Would you consider this typical or likely age? And I'll scroll this down a little so you can see a little bit. We put no. 21 is near the middle. There's 21. But there's nobody really 21, even though that's the average age. I'm not expecting any customers to be 21 years old or even close to 21. Lastly, F. how would you describe the typical or likely age? Well, it says there are two distinct groups of customers. There's children between ages of 6 and 14. There's a bunch of children here. And there's a bunch of adults between 25 and 39 in here. I would say maybe the typical customer would be in this age. 28 and 29 seems to be the most common age, 28, 29. Okay, next page. Okay, this is the same group of data. This is the same customers. And they asked me to make a graph, use two different histograms. Two different histograms. One of them, they said, both will have bins of 10 years. They said make 0 to 9, 10 to 19, and so on. So over here, this was my first one. I did 0 to 9, 10 to 19, 20s, and 30s. But then they said do it again, but start with a different set of numbers. Do 5 to 14. That's still 10 years. That's still 10 years. Then go 15 to 24, 25 to 34, 35 to 44. Each one is still groups of 10 years. Yet look at the data. For this first one, 0 to 9, there's 3 people. So there's 3. And the next one, these are the teenagers, 10, 11. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of those. Next group, there was 9. Next group, there was 4. But when I did it this way, 5 to 14, I did 5 to 14, I had to go, wait, who's 5 to 14? That would be, that's actually all of these ones, isn't it? 6, 7, 8, here's 14. So when I counted those, notice there's 12. 15 to 24, there's nobody 15 to 24 over here. So it says, what do you notice about the data that might help you decide which reflects the ages of the store customers? If I were trying to look at this data, when I look at this, whoops, there we go. When I look at this, it's just not going to work for me. When I look at this data, it looks like all the customers are pretty much right in here, middle age. They're 10 to 29. But when I look at this graph, everybody's either children or older. So entirely different. Where here, everybody's in the middle. Well, here, everybody's on the edges. I could be really confused trying to figure out what type of customers are coming in my store. I want to know that because what items should I carry? Next page. And here's the last question. And don't get fooled in this one. The histogram shows a swim team. How many swim team members are aged 14 or older? Or older. So I might have looked at this, but are older? That's all of these. 14 or older. So I had to count this. This was 2, this was 7, and this was 5. And when I add all that up, that's 14. Okay, next one. And here's the graphs of 2 cars. It says there's 2 cars, the Melody and the Harmony. They are both expected to get 26 miles per gallon. Here's the Melody car, and here are all the dots representing all the gas mileages. Well, here's the other car, the Harmony, and its gas mileages. What's interesting about this problem is that whether you look at this car or this car, well, the mean, median, and mode are all 26 for both cars. Okay, so first question. How does the spread of data compare for the Melody and Harmony drivers? You might notice people that drive the Melody, their numbers are all over the place, aren't they? All over the place. Even though we're supposed to get 26 miles per gallon, there's a lot of people way down here and a lot of people way up here. When I look at the other car, whoop, that didn't work. When I look at the other car, the Harmony, Its average is 26 also, but notice everybody's really, really close to it. So let's look at question B. Based on the data, what can you expect from a group of melody drivers that differs from a group of harmony drivers? We just kind of answered it. These drivers, their gas mileage is going to be really, really close to 26. When they're told they should get 26 miles a gallon, they probably will. Maybe a little less, maybe a little more, but not too far off. They both claim the cars get an average of 26 miles per gallon. It's true. If you actually did the mean and the median and the mode, both of these cars are actually 26. In fact, here's the mode. Here's the mode. They both have 26. But yeah, all three were 26. Who do you think is going to complain? It says, which car will have more drivers complaining about their mileage is much less than 26? Well, it looks like melody drivers, these people down here, they might be saying, hey, look at me, I only got 19, I only got 22. So these people are going to be unhappy. Of course, these people here are going to be really happy, aren't they? And these people are getting what they expected. And that's the end of our slides. Hopefully you enjoyed the videos. Tomorrow, we'll get into the next slides. We'll learn about box and whisker, a lot more about this. We're just taking this kind of slow and easy here so we don't get overwhelmed, because I know distance learning is kind of confusing. Goodbye, guys.